Hello everybody. In at this video, we're gonna talk about addition rule of probability or OR rules. Still, when we have compound events or multiple events, how do we know we're supposed to use addition rules? So when do you use this rule? To get the sum of probability of two or more events. Okay. How do we use this rule? There are two types. One for mutually exclusive type, when there is no common value between two events, or no mutually exclusive, which means they are inclusive. They have a common value. Um, the typical example of a mutually exclusive is when you have event A and event B that they don't have any common, compared to when there is a event A with an event B, there is a common value. That's the non-mutually exclusive. And I say in here they are inclusive. I will say that, but partially inclusive. So let's talk about the mutually exclusive case, which is there is no common values. Event A, event B, if when they ask find the probability of A or B, then that's the time that you add individual event, and they are mutually exclusive, so there is no common in between. So in here, the probability A and B is 0. The common value is 0. So let's look at the example of when that they are mutually exclusive. There are 5 A's, 8 B, and 10C and 15D and 6F at the Math 23 class. Find the probability A students get B grades or C grades. So B grades, once you get a B grade, you are not going to get any other grades. Or if you get a C grade, you are not going to get any other grades. So there is not, they are mutually exclusive. They don't have any common between B grade and C grade. So again, probability of you will get a B grade would be, there are 8 B's out of total. So total would be adding all this number, which is 44. So it would be 44. So your probability would be 8 out of 44. And probability of C would be 15. I'm sorry, it's 10 out of 44. So probability of B or C would be 8 out of 44 plus 10 out of 44. So you got 18 out of 44. Okay. Now, how about we have 5 blue balls and 4 red balls and 3 green balls. Find the probability we pick a ball and it happen to be a red or green. So in here you find the probability of red and probability of green. So probability of red is 4 out of 12 because total is 12, and green is 3 out of 12. So probability of red or green would be 4 out of 12 plus 3 out of 12, which makes 7 out of 12. Because they say or and or, you know, or between two events. So that's why it has to be event between between two different events, and or, and then you add them. So third one, a day of the week that's selected at random. Find the probability is Saturday or Sunday. So Saturday is 1 out of 7. and Sunday is 1 day out of 7. So Saturday or Sunday would be adding this 2, so it will be 2 out of 7. Okay. Another example, 3 local company has the following company cars, and I guess they are sharing the whole one big parking places. So company A has a 50 car, company B has 80 car, company C has 100 cars. So I guess altogether from these 3 companies, 230. If on that table, at this table, find the probability that car is from company A or C. So total is 230. Company A, they have 50 cars. So probability of company A is 50 out of 230. Probability of company C would be 100 out of 230. Then probability of A or C, or C or A, doesn't matter the order. A or C would be 50 out of 230 plus 100 out of 230. So that makes 150 out of 230. Number 2, find the probability that the car is from company B or C. Again, B is 80 out of 230 and C is 100 out of 230. So when you add the same denominator, you just add the numerator. So it will be 180 out of 230. So again, it says or that trigger the addition method of 2 events in this case. Find the probability car is not from company B or C. So the way you do is 1 minus, by using a complementary concept, 1 minus B plus C. So you will end up with 5 over 23 once you get it, and then you take away from 1. Okay. Now, how about the not mutually exclusive? There's common values. When there is common value, P of A or B would be not only you add P of A plus P of B, you have to take away the common one, which is P of A and B. Okay, that's the formula in case you have not mutually exclusive. I say mutually inclusive. So if it's known as mutually inclusive or not mutually exclusive, then you use this particular formula, and you have to take away the common area once, because they count twice from when you count probability A and when you count probability B. So if probability A is 0.5, probability B is 0.4, and probability point A and B is 0.2. So this means that there was a common area. Okay, then find the probability A or B is adding probability A with a probability B and take away the common area, probability of A and B, which is 0.2. Then you end up with a 0.7. So let's look at the word problem, see if it makes sense. In junior class of 150 students, so total number is 150. 100 of them take the math, 80 of them take English, and 50 of them taking both. So what is the probability taking math or English? Okay. So the way you find it is that math or English of probability is math plus English of probabilities, and take away math and English. So total number is 150. So 100 over 150 plus English is 80. So 80 over 250, 150. And take away both is 50, 50 out of 150. So 100 plus 80 minus 50, whole thing, all of them are out of 150s. So 180 minus 50 would be 130 out of 150. So that would be your answer for our purpose, but you can reduce them if you want to, but it's better off that you leave it so we can see where these things coming from, these numbers. So now next one, local factory employee has a following driver license. License C, there are 45 female, 45 male, 25 female, so total 70. And this local company has male with a 30, who has a D drive, and female 10, and total 110. But if you add the males together, it's 75. If you add the females together, it becomes 35, and total number is 130. So number one, find male and who has a D drive. So probability of male and D drive would be male and D out of, so it has to be male and D drive would be like 30. So it would be 30 out of total 110. So you get 30 out of 110. If you are looking for D and male, is you actually get the number which is common between D and male, which is 30 out of 110 again. So male and D is same as D and male. So order doesn't matter. Okay. So these two are same. Male or D, because they are using an N for first two, but now you're using or. So male or D is obviously they have a common in between male and D. So the way you do is you find probability of male plus probability of D, and then you take away probability of male and D. So probability male is 70 out of 75 out of 110, and the one who got D drive is 40 out of 110 minus, and male and D is 30 out of 110. They are all 110. So if you do that, you got 85 out of 110. And because you're using an OR, and because you have a common, the people who has both male and who has a D drive license, that's why this become non-exclusive. Okay. Now the D and male the one who has D drive and male. So the or male, sorry, the or male is male plus D and take away male and D. So you got 75 out of 100, 10, 40 out of 110 minus 30 out of 110. So you end up with, oh, that was C. Oh, so where was D? D again, D or male is D plus male minus D and male. You which 70 out of 110, 40 out of 110 minus 30 out of 110. So you get the same answer. Okay. And E was male C or female. So C or female, C and female. So you add the C and female, and then take away C and female, which is 25. So that's E. Okay. And F, female or D. Because of or again, you get probability of a female, and you add with probability of the D drive, and take away probability of F and D. So probability of female is 35 out of 110 plus probability of having a D license is 40 out of 110 minus probability of F and D. F and D is 10. So 10 out of 110. So when you do that, 35 plus 40 is 75. 75 minus 10 is 65. So 65 out of 110. Should it be E? Or D? D drive 35. Female and D. So it's F. F is 65 out of 110. Yeah. Okay. Now let's combine all this exercise. American Common Sense tests were given to 9th and 10th and 11th, 12th grade. Everybody does well, does their best high school. Here are the results. A is 90%, B is 80% correct, and C is 70% correct. Now, student is selected at random. Find the probability that student is an A student. So total number is 166. A student is 46. So it's a single event, right? So that should be 46 out of 166. Okay. 11th grade. So total 11th grade is 28. So I guess it's 28 out of 166. An A grade student who is in 11th grade. So they are asking AN 11th grade. So AN 11th grade is what? 10? So it would be 10 out of 166. Ninth and C. So C and ninth grade would be 16 out of 166. Number 5 is, so number 5 is a little different. You have I guess it's just a 10th and 11th grade. So 10th or 11th grade is, because you have or, you're supposed to add them. So 10th is 25 of them all together, right? So 25 out of 166, or 11th is 28 out of 166. I'm going to put into one thing, one denominator, because they have the same denominator. So I end up with 53 out of 166. Now, is everything okay? Now, how about then A or B grade students? So A is altogether age 46, and because of OR you add, B grade is all 62 out of 166. So you end up with 108 out of 166. That's for A or B grade. So I guess even though you use or, 5 and 6 is mutually exclusive, because if you get A grade, you cannot get B grade. If you get B grade, you cannot get A grade. They are totally different, so they don't have any common. Same as number 5. If you're 10th grade, you cannot become 11th grade. If you're 11th grade, you cannot become a 10th grade. So they are mutually exclusive. But because 7 and 8, you could get A and also could be 11th grade. Or you could get C and you could get 10th grade. So they are inclusive. They are not mutually exclusive. So you have to take away the common. So for number 7, A and 11th grade, right? So you have to find A. What is the probability of A? It's a 46. And 11th is 28. 28. The whole thing out of 166. So that would be 74 out of 166. Now, tenth or C also, they have a mutually exclusive, this common area. So after that, I guess number 7, you take away the common area, A and 11. A and 11 is 10, right? So you have to take away 10 here. So minus 10 would be 64 out of 166. So contrary to number 5 and number 6, 7 and 8, you have to take away the common area. So number 8, 10 and C. So 10 would be 25 and C would be 58. And then you take away C and 10, which is 7. So 7 away. And everything is in terms of 166. So 25 plus 58 is 83. And 83 minus 7 out of 166 equals 76 out of 166. 76 out of 166. Now you have 10th grade, number 9. 10th grade given B. So I'm going to rewrite this in here. So number 9, probability of 10th given B. Okay. So to find out the 10th given B, my pen is acting weird, but let's make a best out of it. 10th grade given B, so you have to get a probability of 10th grade is the formula for whenever they say given is a probability of 10 NB divided by probability of B. So you're supposed to memorize this formula. Okay. So what is probability of 10 and B? So 10 and B is 10 out of 166. And then you divide this 10 out of 166 with a probability of getting a B, which is 62 out of 166. So 166 and 166 cancel out. Your final answer become 10 out of 62. Because you have a 10 left here and 62 left there. So that's the probability of B given B. So contrary to all other question, whenever there is a given, yes, you're supposed to memorize this formula. Okay, then you are able to do the questions. So number 10 would be B given 10. Probability of B given 10. Again, to do B given 10, like 10 given B was 10 and B divided by B. So B given 10 would be what? Probability of B and 10 divided by probability of 10, because this 10 and this 10 has to be matched. So probability B and 10 is again 10 out of 166. And divide this one by probability of 10 this time, 10th grade is 25 out of 166. So 166 cancel out, you end up with 10 out of 25. Okay. So that's how you find the number 10, probability to be given 10. Okay, try 11 and 12 on your own and compare with the solution key. Okay, and now if you do the summary of what we learned so far, okay, the basic probability summary, probability of the whole thing is 1, which is 100%. Any event A has to be between 0 and 1. That is something called complementary. Okay. And there is a single event and compound events. Or multiple. When you have a multiple events, there are independent and dependent. And when you use multiplication rule, you look for A and D. When you look for addition rule, you look for OR. When you have a multiplication, two events has A and D, that A, probability A and B is the same as probability A times probability B, or probability B times probability A. They're independent. How do you know they're independent? If they say probability A equal probability of A given B, or probability of B equal probability B given A, if they say that, they are independent. Or they imply independent, then they are independent. Then how do you know one is dependent? One is dependent if they give you something given, or one after another that affect second event affect the first event, then they are dependent. Okay. So in this case, dependent case, probability of A and B is probability of A times probability of B given A, or probability of B times probability of A given B. So either one, because you don't know which information is given to you. So you have to know the both formula. Also in conditional probability, probability of A given B is always probability of A and B divided by probability of B. Notice that the denominator match with the second one. Probability of B given A is same as probability of A and B divided by probability of A. Okay. Now, addition rule, mutually exclusive, because two events do not have any common, then you just add them. But if it's mutually inclusive, then after you add them, you have to take away the common value. Okay, so that's what we learned so far. And after that is practice make it perfect. Okay, so these are more like summary of what we learned. Now the next page give us a chart of what we need to know in chapter 5. Chapter 5 probability that consists with single event and multiple event. So compound event is a multiple events. When you have a multiple events, so when you have a 2 or 3, you have to know when to multiply each other or add each other by using keywords A and D or. But even though you do that, each multiplication rule or addition rule has two different each cases, one for independent case for multiplication and dependent case. And the formula they use is similar but a little different. And when you use addition or addition rule, there is an exclusive and not exclusive, and I call that inclusive. There is an inclusive portion in it. And they are similar but yet a little different. So you have to recognize all these differences. So in independent event, you multiply each other, each event. When they are dependent, you multiply given portion. Okay, and sometimes given portion is use a different formulas. Okay. When you have or, you just add it together. If you have exclusive, you have to add and take out the common if you have inclusive events. So that's a summary. Okay. Chapter 3, trees and counting, we're going to skip this. And then we're going to have many exercises. So making sure everybody do the exercises, including exercise 5 and on. So this particular one, I have some summary, and then I have some questions here. Okay. So that's the exercise. All the exercise you have solution key, and they have a step-by-step solution for that. So only the practice make it perfect, especially chapter 5. There are so many things involved with so many different formula, different cases. So many of my students having harder time to following them. So making sure you do many exercise so you can understand each problem. And if you have any question, you can ask me on the regular session. Okay, so I will see you on next video. Okay. And that's it for today, and I will talk to you soon. Thank you.